Okay, we've constructed a segment that represents the reciprocal of the cosine. Now we want to find something that represents the product of the reciprocal of the cosine with the sine. And this is something you really should think through. Okay, you really shouldn't wait. You really shouldn't go ahead and let me show you how to do this. You should think it through, because this is well in the realm of things that anybody who's had a geometry course should be able to do. Might have to think a little bit, but it's not all that difficult. And then, I don't like to continually express my opinion of the geometry courses that are being taught, but sometimes I can't help myself, and I can understand why somebody might not understand what to do here. Okay, well, I start by constructing, I'm going to construct a right triangle. Okay, and if you haven't thought of doing that, then you probably really ought to. Okay, construct a right triangle with 1 over cosine, and I always need to use my unit distance. Now, actually, I don't always need to use my unit distance, because there's a way to do all of this without, in fact, using the unit distance at every step. But we're going to go ahead and use it here. Okay, so I'm going to construct a right triangle now. Again, I use the word construct. I'm not constructing, I'm sketching. It has side 1 over cosine and another side of 1. Now, I would hope that, given what you've seen, you would have thought of doing that. But if not, there's a big hint. Again, you should stop and think some more if you haven't thought of constructing this triangle. I'm going to continue, but hopefully paused and thought about it if necessary. Okay, so how am I going to get the sine times reciprocal of the cosine? If I put a length 1 here, I'm going to get a triangle, and this side of the triangle is going to be what? Okay, well, you can think about it, but it's not going to be the sine over the cosine. It's not going to be the sine multiplied by 1 over cosine. Matter of fact, I've got to use the value of the sine. So I'm going to go ahead and measure the value of the sine corresponding to this point. Right here it is. I'm going to have to put this someplace. I could put it here on this leg. I could put it here on this leg. I really don't want to put it in the hypotenuse, because the hypotenuse has to be longer than either of these legs, and sometimes the, well, it could be done, but for that reason, we aren't using the hypotenuse. If there's a good reason to use it, okay, but the hypotenuse is related to these by the Pythagorean theorem. You end up with squares of these things and then a square root, and it's not going to lead you to anything very useful. Okay, but what I'm going to do is, got to pick a good color here, and I'm kind of out of good colors. Going to construct my value of the sine. Now, should I put it here? 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 If you haven't thought about those possible alternatives, again, you really should. Okay? Okay, I'm going to choose to put it here. So now this side here is my value of the sine. And I want to get a similar triangle similar to this one. So if I put my sine here, to make a triangle similar to the one I've already got, I'm going to have to construct a side parallel to this one. So I'm going to attempt to sketch that side. Okay, so this side is my sine. And I claim then that this side is my sine over my cosine. Now, again, this is not the only way to get a segment whose length is equal to that of the sine over the cosine. Okay. It's not even the best way. I'm leaving it to you to play around with similar triangles, which is something that everybody can use practice with, and see if you can find a more efficient way to construct this. But this works. So right here is sine over cosine. Okay, now you notice sine over cosine is less than 1. Okay, and if you look here, the sine is less than the cosine. And if I take this segment here and divide it like this, it should be the same as this segment 1 here divided here. You should have geometric similarity between the segments. And I'm not going to talk too much more about that. It's something, again, I want you to think about, and I don't want to get too prescriptive. In any case, okay, my sine over my cosine is then this. Okay, so this point is just a little higher, corresponding to this horizontal position than that of the cosine graph. So I've constructed one point on the graph of the tangent. And I can write tangent equals sine over cosine.